Let's take a look at the compound inequality. Minus 2 plus 5x is greater than 3, or 5x over 2. 5x over 2 is less than or equal to 1. All right, so let's go ahead and deal with these individually. So we have minus 2 plus 5x is greater than 3. We're going to deal with this one first. We want our variable on the left side, everything else on the right side. So let's add 2 to both sides. That term cancels, so we have 5x on the left-hand side is greater than 3 plus 2 is 5. We divide both sides by a positive 5. That isolates our x terms, so we have x is greater than 1. That's one of our inequalities. Well, let's deal with the second one now. We have, let's go ahead and rewrite this as 5 over 2 times x is less than or equal to 1. I don't like including my variable in the numerator if I can help it. I like to separate them. And let's go ahead and solve for x. Here it makes it a little more clear what our reciprocal is when we're multiplying. So we're multiplying the entire inequality by 2 over 5. That'll cancel out that term. So we have x is less than or equal to 2 over 5 times 1 is just 2 over 5. So we have our two inequalities, and we want to see what the solution graph looks like for the compound inequality x is greater than 1 or x is less than or equal to 2 over 5. So let's go ahead and graph this thing. So we have, let's go ahead and put 0 in the middle. Doesn't need to be too big as far as scale. The numbers are, oh, I don't know what I'm doing here. Let's try this again. So we have 1 and 2, and this is going in the negative direction. Okay, so we're looking for all the values that are greater than 1. We're not including 1 because we just have a greater than sign, so we're going to put a parentheses opening to the right here, and we'll be shading to the right. We can go ahead and do that because we have an or compound inequality, and we don't have to worry about the solutions overlapping. So the second region is going to be all the numbers less than or equal to 2/5. 2/5 is somewhere about right here. And we're going to include 2/5 in our solution set, so we're going to put a bracket there, opening to the left, and since we're interested in all the values less than 2/5, we're going to shade to the left. And that's the solution graph for this compound inequality. Alright, let's go ahead and look at the next one. We have the compound inequality x minus 1 is less than 4, or x minus 1 is greater than 9. Okay, these are actually pretty simple, so let's go ahead and take them one at a time. So we have, if we add 1 to both sides of this equation, these two terms will cancel, so we have x is less than 5. And as far as this equation goes, we can do the same thing. These two terms will cancel, and we'll have x is greater than 10. All we did is shift our graph, our solution graph, one place to the right. So we have x is less than 5 or x is greater than 10. So let's see what the solution graph looks like. We should be getting pretty good at this by now. Let's go ahead and put, let's put 7 there. 8, 9, 10. Here's 10, 6, 5, 4. So here's 5. And we want all the values less than 5 but not including 5. So all the values to the left of 5, we're going to put a parentheses opening that direction and shading to the left. Here we're interested in all the values greater than 10, excluding 10. So we're going to put a parentheses here, opening to the right and shading to the right. And that one was fairly simple. So let's go ahead and do another one. Let's take a look at 3x plus 2 divided by 2 is greater than or equal to 3, or minus x over 4 is greater than 11 over 6. Alright, so we have some fractions here in an or compound inequality, but don't get excited here. We actually know how to do this, so let's just take it one step at a time. Let's deal with this one first. So we have 3x plus 2 divided by 2 greater than or equal to 3. Let's go ahead and get rid of the fraction first. by multiplying through the entire inequality by 2. The denominator is going to cancel, so we have 3x plus 2 is greater than or equal to 2 times 3 is 6. Now we can move, we have our variable on the left side, we can move everything to the right side, so let's subtract both sides by 2. We have 3x greater than or equal to 6 minus 2 is 4. And we can simply finish off by dividing both sides by 3. That'll give us x is greater than or equal to 4/3. All right, let's take a look at the next one. So we can rewrite this as minus 1 over 4 times x is greater than 11 over 6. Let's go ahead and multiply the entire inequality by the reciprocal, or the negative reciprocal, of the coefficient of x. So we have minus 4 over 1. That way we'll actually have this side solve for a positive x instead of a negative x. That will cancel. So we have x. Now we're multiplying by a negative here, so we're going to flip our inequality sign from greater than to less than. And minus 4 times 11 over 6 is minus 44 over 6. That will simplify, so let's go ahead and do so. So this will simplify if we factor out a 2 out of the top and the bottom. We have minus 22 over 3. So this is our compound inequality, or the new version of it. X is greater than or equal to 4 over 3, or x is less than minus 22 over 3. And all we have left to do is just quickly sketch the graph of it. Just a rough sketch. This goes in the negative direction, this goes in the positive direction. It's not really straight, but we can just squint really hard and imagine it is. So we have, let's go ahead and put minus 3 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 4, 5, 6, 7, 8. Here's minus 8. Here's minus 7. And we have 2, 1, 0, 1. So this is plus 1 and 2. I'm just writing out a few of the important values. You can actually fill them out later if you want. So we're interested in the values that are greater than or equal to 4 over 3, or 1/3, which appears right about here. And we want all the values to the right of this point, and we're going to include this point in our solution set. So we're going to put a bracket here. We're going to shade to the right. So that's this one. X is greater than or equal to 4 over 3. Now here we want all the values that are less than minus 22 over 3, which is right about here. Now we're not including the value minus 22 over 3 in our solution set, so we're going to put a parenthesis here. And we want all the values less than this value, so we're going to shade to the left. Those are our two regions. We should have two regions because it's an OR compound inequality. All right, so we're working with solving compound inequalities. There's not a whole lot to them. There's nothing that we actually don't know how to do. So we're just using what we know, taking one step at a time, and making life simpler on ourselves when we can. So we actually have one more to do, including an application of a compound inequality, and we'll do that in the next video. So I'll see you soon.